You ever wonder how a video game can just spawn an entire army of enemies out of thin air? Or how your social media feed just keeps on scrolling forever? Well, it all boils down to one simple but unbelievably powerful idea in programming. So today, we're going to pull back the curtain and demystify the loop.
So, what could possibly connect finding prime numbers, drawing little pyramids of stars, and analyzing a bunch of data? Yeah, I know, they sound like they have absolutely nothing to do with each other. But deep down, at their core, they all run on the exact same instruction, a single command that really unlocks a computer's true superpower: repetition. And that concept, it's the loop. At its heart, a loop is just automated repetition. Think about it like this. You need something done 1,000 times. Instead of you doing it 1,000 times, you just write the instruction once and tell the computer, hey, you do this 1,000 times for me. It's the ultimate shortcut. Okay, I know, this looks a little scary, like some kind of cryptic code, but it's a perfect, simple example of what we call a for loop. All this thing is doing is telling the computer to print out a multiplication table. It's got 3 parts, that's it. Part 1 is the setup. It creates a counter, I, and starts it at 1. Part 2 is the rule. It says keep going as long as I is 10 or less. And part 3 is the what's next. After each go around, just add 1 to I. And it just does that over and over until it hits 10. Simple, clean, and super efficient. So just repeating stuff, super useful. But what if we can make it smart? What if every single time it repeated, the loop could actually look at a piece of information and make a decision? Well, that's when a loop goes from being just a workhorse to being a real mastermind. All right, let's try a little problem. Imagine you've got all the numbers from 1 to 100, but you only care about the odd ones. A basic loop would just spit out every single number, one by one. We need our loop to think a little, to actually filter the results. We need to give it a brain. And the solution is just this one extra line tucked inside our loop. Now, don't let that little % sign scare you. It's called a modulo, which is just a fancy way of asking, what's the remainder after you divide? So this line is literally just asking the computer, hey, when you divide the current number by 2, is the remainder not 0? If the answer is yes, then hey, it's an odd number, print it. If not, the loop just says, okay, next, and zips right past it. And this is where things get really cool. This ability to make decisions is what makes loops so powerful. We can use that exact same remainder logic to hunt for something way more complex, like prime numbers. For every number, the loop can ask, can this be divided evenly by anything other than 1 and itself? The loop is the muscle, doing all the heavy lifting, and that little if statement is the brain, making the call on every single pass. All right, so check 1, loops can repeat. Check 2, they can make decisions. But what's next? What if they could also remember things? What if instead of just spitting out a bunch of different results, a loop could actually build towards one single final answer? This is where it starts to feel like loops have a memory. A perfect example of this is calculating a factorial. To get the factorial of 5, you have to do 5 times 4, then take that answer and multiply it by 3, and so on. The loop has to remember the running total at every single step of the way. And here's the trick. Before the loop even starts, we create a variable. Just think of it like a little box to hold a number. We'll call it P, and we'll put the number 1 inside. Then, every time the loop runs, it takes the number that's already in the box, multiplies it by the next number in the sequence, and puts the new result back in the box. It just builds and builds the final answer, one step at a time. And you know what's cool? This idea works for tons of stuff. You want to find the sum of a bunch of numbers? Just swap out the multiplication sign for a plus sign. The concept is exactly the same. Repeat, remember, and build. Okay, you ready to go a little deeper? Like Inception deep? We've seen what one loop can do, but the real magic starts when you nest them, when you put one loop completely inside another one. This is how we start creating complex patterns and structures. Let's say we want to draw a pyramid of stars. The trick is to think of it like a manager and a worker. The outer loop is the manager, and it's in charge of the rows. On its very first pass, for row number 1, it turns to the inner loop, the worker, and says, okay, your turn. I just need you to run once and print 1 star. Then, the manager, our outer loop, starts its second round. It's now on row 2. So this time, it tells the worker loop, all right, I'm on my second pass, so I need you to run 2 times now. And the inner loop says, you got it, and prints 2 stars. And I think you see where this is going, right? On the third pass of the outer loop, the inner loop runs 3 times. The outer manager loop controls how many rows we get, and the inner worker loop controls how many stars get printed on each of those rows. And this is the code that makes it all happen. And honestly, it's way simpler than you might think. The outer loop, with its counter I, just runs from 1 to 10 for our 10 rows. But look at the inner loop. Its counter K only runs up to whatever number I is on it at that moment. So when I is 3, the inner loop runs 3 times. When I is 7, it runs 7 times. That little connection is the whole secret sauce.
Okay, so let's recap. We've got repeating, we've got deciding, we've got remembering, and we've even got loops inside of loops. So what now? Well, let's put all these pieces together and build something that's actually useful, like analyzing a set of data from a user. So check this out. First, we've got our for loop. That's our workhorse, just asking the user for a bunch of numbers over and over. But inside that loop, we've got our if statements making decisions, constantly checking, hey, is this new number the biggest one I've seen yet? Or is it the smallest? And at the exact same time, it's using that building logic we talked about to keep a running total so we can get an average later. It's all happening at once, repetition, decision-making, and building, all working in perfect harmony. So, once the loop's done its job and gathered all the numbers, just one tiny little division calculation later, and boom, there's our average. And remember that clever little if statement that was comparing everything? Well, that's how the program kept track and remembered the absolute biggest number that was entered. The exact same logic finds the smallest number. And just like that, with just a handful of code, all powered by one single loop, we've just done a complete statistical analysis. That is the kind of power we've been building up to. So let's just step back for a second and look at the journey we just took. We started with something that could just print a simple table. Then we gave it a brain to make decisions. Then we taught it how to remember and build things. And we put it all together to create a smart data analyzer. And the engine that drove all of that? Yep, the Humble Loop. At the end of the day, a loop is the heart of automation. It lets you tell a computer to do thousands or even millions of things with just a few lines of code. So I'll leave you with this question. What repetitive, boring, or complex task in your world could be totally simplified and solved with the elegant power of a loop?